Welcome to the Functional Python series. In this video, I want to introduce map and filter. Map and filter are the workhorses of functional programming. And that is because many programs are about processing collections of objects. And the goal of the program is to transform these collections into other types of collections. As usual, the code for this video is in GitHub, and you can follow a link in the description to this repository. One of the interesting aspects with map and filter in Python is that they are built-in operations in Python. As you can see here, map and filter, they're both built-in functions. That basically means that from the very beginning, the design of Python thought of functional programming style processing of data. They provide easy and efficient stream processing, and we'll see that they're extremely useful to write elegant and simple code to solve many problems dealing with processing collections of data. So let's first look at the syntax of both of them. They're relatively simple. Both of them take a function and a stream. Map takes this stream, and for each one of the elements, it applies the function f to it, and it generates a stream with the resulting values in the same order. Filter, as its name implies, removes elements from the stream. It only keeps elements for which calling f on the element returns true. In other words, if I call f in an element of the stream and this function returns false, then this value gets thrown away. And again, it returns a stream with the elements in the same order as in the original stream. So let's look at an example. This code is a little bit contrived, but it demonstrates that we can do a lot of processing in just one single expression, one single line of code. Here's the problem. For all even numbers between 0 and 9 that are even, print the number and its square. Okay? And I have added extra lines to demonstrate how it works. Unfortunately, because of the syntax of Python, we have to read stream processing from the right to the left. So we start with generating the sequence of numbers between 0 and 9 by using range. This is a stream. And then we filter those ones for which this expression, this lambda expression, returns false. Sorry, we keep the ones for which this function returns true. So essentially, we keep the ones that they are even. And then finally, the map takes each one of the elements of the stream and creates a pair with that element, and then the square as the second of the pair. And finally, we convert this into a list. We'll see why in a few minutes. And then we print it, okay? And we get exactly the values we expect. 0, 2, 4, and 6. Sorry, 0, 2, 4, 6, and 8, and the corresponding squares, okay? But don't write code like this. What I do, and this is my preferred way, is number one, I avoid anonymous functions. And I should put this below. If the function is very, very trivial, then I create a lambda, but otherwise I give it a name, okay? The other thing I do is that I only do one operation per line. I don't want to overload my brain trying to understand what a line of code does. I want it to be relatively obvious by looking at the code what that line does. And then finally, I shadow the previous value of the stream to avoid creating lots of variables. This will become more obvious if we follow the example. Here's the same code. It's significantly longer, but much more readable and maintainable. The core of my processing is done in this function, even and pair with the stream. It takes a parameter, the stream, and then it applies the function isEven that returns true when the number is even. And I assign this to result. Then I pass this result, the stream, to map with the function pair with square, which is responsible for creating the pairs as we expect. Notice that I will use the same name on the left-hand side that in the right-hand side. This is to avoid having too many variables in my code. I know that after this operation, I will never use the original result from line 17 again. So I'm basically just overriding it. I'm basically shadowing the value of the previous result. And then I return this string. So now line 21 is the one that creates the original string, the range of numbers from 0 to 9 with a range of 10. Then calls my even and pair with the square, which returns a string, and converts it into a list, which then I print. And I get exactly the same result than before. So no surprise here. I just strongly believe that this is much easier code to read than the one that we had in the previous slide. This might show that you are a great functional programmer, but it's not very useful code. Well, this actually is code that a good software engineer will be very proud of, because it's code that is easier to read and maintain even by people who didn't write the code in the first place. Okay. So, but the true benefit of map and filter is that they are lazy. Remember, streams are lazy computation. So map and filter process streams and return streams. Therefore, they're also lazy. Let's look at what does that mean. What if I don't call list? So this is exactly the code that I had in the previous slide. The only difference is that I did not call list here. Okay. So let's run this code. This is the output. Okay. I get a map object, which is a string. It means that even and pair with the square has not done anything yet. The processing actually happens when I start to traverse the stream with next. Okay. Let's look at this example, same code, but now I have extra prints to be able to see what's happening. Okay. To understand better how filter and map are working here, think of them as a production line. We have a production line where a stream comes in one side and a stream comes in the other side. And each station is a call to one of my functions, filter or map, which are the only ones that we know so far. So here is where I'm setting off my production line. I'm basically saying the input to my production line is the stream. And then the first thing I'm going to do, my first station, is going to filter the ones that they are not even. And then the second station is going to create the pair. And finally, I return the result. So if I call this function, this production line setup, with this huge sequence from 0 to this, who knows, trillions, quadrillions number, then nothing happens. This is the same code as I demonstrated in the previous slide. We're essentially having a stream, and then I can start processing it. So let's look at this and see what happens. So notice that I have added the print statements. So we can see when we go into pair with the square, we can see when we go into is even, and then we can see also when we are asking for the next result. And here's what's happening. Give me 1. So we go into even with 0. Of course, this is even, so it's passed to pair with square. And then pair with square does what it needs to do and returns 0, 0. And the production line stops there. Then when I run next again, the production line gets woken up, and then the number 1 is the next number. This is not even, is disposed. Then filter calls the next one, which is asks for the next one, which is a 2, is passed to is even, and says this is true, so it's passed to pair with the square, and we get this result. And the production line is stopped, and then the same happens again and again. So this is one of the great benefits. And you might say, yeah, but this is actually a little bit contrived. I'm not going to write programs like this. Okay. So let's make it a little bit more interesting. Let's say that I want to have this production line that processes at most end results. If I pass none or I don't pass the end parameter, it will process all of them. But I can say, I only want to process n, so give me that number or not. And then in here, when I set up my production line, I can say my production line will process at most, it will return at most n elements. So I do my filter, I do my map, and then I use this function from itertools. We will have a video dedicated to itertools because it's extremely powerful. This is a built-in module within Python, which says, I take a stream and I will return as much n elements from it. If you pass me a none, then I will return everything. So this is not processing the stream. This is basically saying at most I will do n elements. And then I can convert it into a list. And in this case, it will only actually do the first 4. So notice how the processing starts to happen. So we process 1, 2, 3, and 4, and we get the result that we expect. Okay. So this is actually why it's beneficial that we have lazy processing, because I don't have to worry about how much data I'm processing. I don't have to worry about, oh, I'm going to process with map a huge list, so therefore I'm going to create a new huge list. No, all the memory takes is the necessary to process one element. It returns it extremely fast, and it goes to the next one and the next one and the next one and the next one. So very, very efficient processing. Okay. So let's put everything together and let's try to solve a real problem. And when I say everything together, several of the videos that we have so far. So let's start with this assumption. We have 2 CSV files. This is the schema of the first one, order ID, customer ID, date, and amount. And then the second CSV file is customers with the customer ID, CNAME, contact, and country. The 2 CSV files are connected via the customer ID field. And we want to compute a join, which is equivalent to this query in SQL. Okay. Select order ID, date, country from orders, join customers using customer ID, where country equal to Germany. So this is a very simple SQL query. Let's try to do it in Python. So first, let's convert it into a cross product. So a join is syntactic sugar. It can be rewritten as a cross product. So let's do it with a with expression. So let's create a subquery with the cross product with a where clause. So this is equivalent to the join. And then let's process the join table and then just output the order ID, date, and country for where the country is Germany. Okay. Let's do it in Python. We can use the query as the blueprint for an implementation. And we can follow it almost one step at a time in almost identical form. We start by doing the cross product of orders to customers. And then we match the orders to customers using the customer ID. This is essentially the join. And then we keep the tuples that have the country equal to Germany, the selection. And then finally, we project only order ID, date, and country. So how do we do it? First, I want to create name tuples because that makes my code less brittle and easier to read. And then I get some help at runtime if I make mistakes using wrong indices for the different attributes of the CSV file. So line 32 is essentially just opening the CSV files. 34, CSV reader creates a stream that takes a file, an input file, in this case forders, which is the orders.csv, and returns a stream of tuples, each one corresponding to a line in the CSV file. And then we use map to convert this list because CSV reader reads a list for every line in the CSV file. And let's convert it into a list of orders. So notice actually I have here my collections. So I could have the attributes order ID, CID, date, and amount, kind of similar to what we have in SQL. So this is essentially using map to be able to create that, but it still keeps it as stream. We do the same with customers. So we read the file customers as a CSV file, and then we convert that into customers. Notice actually I'm passing here a tuple to a function that expects, in this case, 3 parameters, but using the star operator, I can pass just the list, which is actually one of the nice features of Python. Okay, so now we have in orders the orders and in customers the customers. So let's do the cross product. There is a function in the third tools that does that. It takes 2 streams and creates a new stream with the cross product of them. So let's do the same as we did with the customers and the orders, and let's create a name tuple with the tuple of with the product. itertools product returns a pair for each element of the stream, and but I don't really want to deal with pairs and arrays, so I instead want to actually deal with this data structure. Okay, order ID, CID, date, amount, CID2, CNAME, contact, and country, which is just concatenating order with customer. I use CID2 because I need to use different names for the customer ID. Okay. Okay, so I have done that. Now I can do the join. So the join is a filter where the CID of the order has to be the same as the CID of the customer. So keep only those ones that match. So at this point, now I have the join of the two CSV files. Let's do now the selection. Keep the ones for the country is Germany from the join that I computed. And finally, let's do the projection. Convert the entire tuple that we have to this string. I'm just going to return a string. Order with the ID of the order, the date, and the country. And that's all. And then finally, let's process the stream. Let's consume it. Let's remember at this point, up to this point in line 54, we have created at our production line. The only thing that has happened is that the files are open. Our stations are ready to process the files. And when we called list, that starts happening. I have an extra operation, which is the map print. Let's actually put it here above so we can see that map print of the result. And let's just call list of result. And that's all, yeah. If I run it, this is my result, okay? In the variable result, actually, I don't even need result at this point. It has already been printed. The moment that I call list, the moment that the stream result gets processed. So what does result have? It has a filter, it has a map, and a map. A filter of what? Of join. Oh, so this is actually connecting another production line. What is that production line? Is this joined? That is a cross product. Oh, it goes to another production line. I could have used the same name in all of these streams. I just wanted to use a different one so to make it clear what operations I'm doing. But notice that the moment that I use cross in lines 47, I never use it again. So I could have used result in all of them. So this is my set of production lines. And overall, they create extremely clean and simple to read code. The important aspect here is notice, how many for loops did I have? How many if statements did I have? That is one of the benefits of this type of processing. Another one is, what are the potential sources of errors in this code? Obviously, if I create the wrong lambda, why call the wrong function? But each one of these stages is so simple that I can quickly debug it and make sure that it works before I go to the next station. I only have to worry about what happens at each one of the stations. What data it gets and what data it gets out. So in my opinion, this is a better example of the beauty and the elegance of functional programming using map and filter in Python, and some other features that we have gone through. So in conclusion, map and filter are the foundation of functional programming. They're both lazy and they allow for very elegant, simple code to do complex processing of collections of data structures. As usual, the code for this video is in GitHub, and here are some links to extra documentation for these functions. And itertools, which is a great library, and we'll talk about it in next videos. Thank you.